In this review, we're just going to take a look at these 4 factoring problems and how you would factor them. So remember, we have so far only learned about factoring problems where there is an invisible 1 out in front here. Okay, so notice there is nothing here. The strategy that we're using right now only works if there is an invisible 1 here. And that strategy is that if I can think of 2 numbers that add to this second number and multiply to this last number, okay, so in this case I need 2 numbers that add to 14 and multiply to 40. I can actually just kind of plug them into this little setup here, right? So in this case, I'm thinking, okay, 2 numbers that multiply to 40, like 5 times 8 is 40, 4 times 10 is 40, 2 times 20 is 40, right? I'm looking for a pair that adds to 14, which is right here. So my 2 numbers are 4 and 10. In this case, they're both positive, right? This is positive 4 and positive 10. So I'm going to write x plus 4 and x plus 10. And this is my answer. Now, if you don't trust that, right, you could multiply it back out. You'd get x times x would be x squared. X times 10 would be 10x, and this would be 4x. That would add to 14x, and 4 times 10 would be 40. Okay, so there's our answer. So again, I notice this has nothing out in front of it, and so I am looking for 2 numbers that add to negative 10 and multiply to 16. They add to negative 10 and multiply to 16. Okay, how could 2 numbers add to a negative and multiply to a positive? Well, remember, if I want to multiply to a positive, that's either going to be a positive times a positive or a negative times a negative. Okay, now I need to add these 2 numbers and they need to add to a negative. So that's going to be 2 negative numbers. Okay, it's going to be 2 negative numbers. If it multiplies to a positive and adds to a negative, it's going to be 2 negative numbers. So what are 2 numbers now that multiply to 16 and add to 10? Well, multiply to 16, let's see, right? I have 1 and 16, 2 and 8, 4 and 4. And these 2 add to 10. So in this case, it's going to be negative 2 and negative 8, right? Negative times negative is positive 16. Negative 2 plus 8 more negatives is 10 negatives. So my answer looks like this. X minus 2, x minus 8. Let's take a look at this one. There's something here that's been getting a lot of people tripped up. Okay, so first, let's notice, right, there's an invisible 1 right here. So again, I'm using my strategy. It adds to this number. What is this number right here? It's a 1. Okay, so I'm looking for 2 numbers that add to 1. In this case, it's a positive 1. If this was a minus x, then it would be a negative 1. But in this case, it's adding to 1, and it's multiplying to negative 90. Now, if I have 2 numbers that multiply to a negative, it's going to be 1 positive and 1 negative number, right? That's the only way that I can multiply and get a negative. So when I go ahead and add these, they're going to subtract. So now I'm thinking of 2 numbers that multiply to 90 and they subtract to get 1. And so hopefully when you think of 90, right, you don't start with like a 1 times 90, 2 times 45, 3 times 30. That's not wrong. But hopefully 9 times 10 pops into your head and you realize, well, if I do 10 minus 9, I get 1. And so since I want them to add to positive 1, this bigger number is going to be positive 10, negative 9. And this will be 10 minus 9 is positive 1. Now let's say this was a negative right here. Then I would want them to add to negative 1. And I would make the 10 negative and the 9 positive, right? That would be 9 minus 10. That would be negative 1. But for this problem, the answer is x plus 10 and x minus 9. And in this last problem, I notice, this isn't a 1x squared. Look, this was 1x squared. This was 1x squared. This was 1x squared. So this actually has a greatest common factor that I can pull out before I start factoring. And I'm going to go through and I'm going to look at the numbers first. And here 7 is the smallest of the numbers. And I also, I kind of just know that when I go to factor it, this is going to have to be an x squared, right? So you can kind of think about what's going to have to come out of it. And so I noticed that this can be divided by 7, this can be divided by 7, this can be divided by 7. And I also noticed there's an extra x on each of these, right? Like over here, I had 2 x's, 1 x, no x's. Here I have 3 x's, 2 x's, 1 x. There's an extra x. And so my GCF is 7x. Okay, so 7x times x squared is 7x to the third. 7x times what is 42x squared? So 7 times what is 42? If you don't know, you put in your calculator 42 divided by 7, get 6. Okay, and here there's 2 x's, here there's 1, so I'm going to need 1 more x. 7 times what is 35? 7 times 5 is 35. And there's already an x here, and there's already an x here, so I'm set. Okay, so now I'm going to take this, and I'm going to just focus on this, and now this problem is just like the ones I just did. And so I'm going to just click, I can cover this, and I'm going to say, okay, now I have this x squared here, so I need 2 numbers that add to 6 and multiply to 5. And here's the thing, a lot of times we overthink this, but there's only 2 numbers that multiply to 5, right? And it's 5 and 1. So this is 5 and 1. And so look, I'm going to bring down this 7x, and then I have x plus 5 and x plus 1, right? Because 5 and 1, they multiply to 5, and 5 plus 1 is 6. And this is the answer.